Alright, so we're going to go over the difference quotient. So what is the difference quotient? The difference quotient is used to find the average rate of change for a single point. So to understand difference quotient, we're first going to understand what average rate of change is. So let's say I have this line, and I want to find the average rate of change between 2 points on this line. What I would do is I would take the value, I'd find the change in the y over the change in the x. Now this is very similar to slope, right? So for a line, the average rate of change is going to be the same as slope. So for in this case, it would be y minus y2 over x minus x2. Okay, but how do you do that for a curve? So if I draw out a curve, what happens is that now you don't have a slope to work with, right? So let's say I have a point here and here. So now I have to draw an imaginary line here, and you see that this line wouldn't match with the actual curve. All right. So I have to find this point and this point, and I just have to subtract them, right? So if I were to do x1, y1, x2, y2, the average rate of change would just be the change in y over change in x, or in this case, the slope of this line that we draw through our two points. So it'll be y2 minus y1 over x2 minus x1. Now, what happens whenever we have to find the average rate of change of a singular point? So what happens is we have a graph, and it says find the average rate of change at this singular point. Well, there's no line to draw because we can draw infinite numbers of lines that can go through this one point. So how do we do that? So in this case, we will use what's called the difference quotient. Now, instead of just writing out the formula, we're going to see how we can actually derive the formula so we know how this works. So first, how do we derive the formula? Well, we're going to say, let me actually just draw the graph in green above here. So let's go back to our 2-point example, right? Let's call the x value of this point A, and this point will be at a distance of an h away from A, meaning that the gap between A and this point will be of h. So in this point, we can do A plus h, right? Now the y of this will be f of A, while the y of this point will be f of A plus h. So I'll actually draw these on the y-axis over here. So f of A, and here will be f of A plus h. What I'm doing here is that assuming that this green line is f of x, you know that if you have something like f of x equals x plus 1, your point on your graph will be 1 comma f of 1, right? Because if you plug in 1, you'll get 2. So f of 1 would be the same as 2. So we don't actually know what these will evaluate into, so we can just leave this as f of whatever our input is. So this is our input and our output. So our x and our y is our input and output. Now, to find the average rate of change, right? What we're going to do is we're going to do the change in y over the change in x, right? So the y of this will be f of a plus h, f of a plus h, minus the y of our point here, which would just be f of a, over our x of our second point, so a plus h, minus our x of our first point, a. Now we can see that on the bottom, a plus h minus a, this a cancels with this a, so we're left with f of a plus h minus f of a all over h. And in the actual formula, you would see this written out mostly as f of x plus h minus f of x all over h. Now, the actual labeling of these variables don't really matter too much. It just matters. This is just standard convention. What really matters is what do these actually do? Well, we know that f is our function. So what is x? Well, this is our x value of our starting point. So x value of starting point. And what is our h? Our h is going to be the distance, or h in this case is going to be the distance between our 2 points. Horizontal distance. So h is going to be our horizontal distance between our 2 points, right? So now that we have our difference quotient and we know what each things are, let's try tackling that problem again. So if I have my function and I say solve for this point, right? Whenever we plug it in, let's say this is 4, we're going to do f of x plus h minus f of x all over h, right? What is our x? It'll be 4. And what is our distance? Well, it's the same point, right? So it will be 0. F of 4 plus 0 minus f of 4 all over 0. But we have a problem here. We can't divide by 0. So what we instead have to do is we use our difference quotient formula and we plug in our function, right, to make it so that whenever we plug in the h of 0, it doesn't become undefined. So let's try this with a practice function. Now this function is going to be f of x equals 1 over x plus 2, right? What is the difference quotient for this function? Well, we can plug it into here, right? So on the top, if I were to plug x plus h into my equation, I'll get 1 over x plus h plus 2 minus f of x. Well, we know f of x is just this. So it'll be minus 1 over x plus 2 all over h. Plus 2 minus x plus h plus 2 all over x plus h plus 2 times x plus 2 and all of that over h. X cancels out with x, 2 cancels out with 2, and this now is 0 minus h, so on top we have a negative h. This is the same as negative h over x plus h plus 2 times x plus 2 all over h. Now if you solve this out, you are going to get negative h over x plus h plus 2 times x plus 2 times 1 over h, right? Because multiplied by the reciprocal, these cancel out and you get negative 1 over x plus h plus 2 over x plus 2. So this is our difference quotient for the function 1 over x plus 2 just by plugging this into our difference quotient formula. The main thing that we've done here is whenever we plug in a h value of 0, the denominator will not be 0 and it will not give us an undefined result. So how do we use our difference quotient? Let's say I were to ask you what is the average rate of change at 4. What is our starting value, or our x here? Our x would be 4. And what is our horizontal distance between our points? Well, we just have 1 point, so h will be 0. If I plug this in, negative 1 over 4 plus 0 plus 2 times 4 plus 2. That will get us be 6 times 6 will be 36, so negative 1 over 36. So in the function 1 over x plus 2, at point 4, our graph has an average rate of change of negative 1 over 36.